Welcome to Fast Math Solutions on Maths with EJD. In this video, we will focus on the solution of arctan of x dx. Now, just like arc sine of x and arc cos of x, integrating those, just like that, you may not be able to integrate this directly, but we know that we can use the idea of integration by parts. For instance, we know that the integral of u dv is equal to uv and the integral of v du. So you need a u which can easily differentiate to get du. You need a dv which can easily integrate to get a v, like there. So we know that since we cannot integrate directly, we could as well just say that we could as well say let u be equal to arctan of x, okay? And then automatically dv would be dx. So this is u now, and this is dv. So because we need u dv, okay? So we can now deal with this. So this is it. So u is something you can easily differentiate, and to differentiate this, we can take tan of both sides. We can take tan u equals x. If you take tan of both sides, tan cancels out tan. So you now need d dx of tan u equals x. And then you go on and you have d du. Since you cannot differentiate tan u with respect to x, so you have to say d du tan u multiplied by du dx to balance that out, so that du cancels du, and you still have your d dx as expected. So we can do that. And this is d dx of x. Okay, so the next thing is d du of tan u. If you differentiate tan u, you get sec squared u du dx. And that is d dx of x is 1 simply. And that means that du dx is equal to 1 over sec squared u. Now, you did not start with sec squared u or anything u. So you have to make sure you also get rid of u as much as possible. So what do you do in that case? Now, you know that the last x you had was here, tan u equals x, right? So how do you bring that here? Then you remember that sine squared u plus cos squared u is equal to 1. If you differentiate through by sec cos squared u, sine squared u over cos squared u is tan squared u. Cos squared u plus cos squared u is 1. 1 over cos squared u is sec squared u. So you can say that cos squared u is actually tan squared u plus 1, or 1 plus tan squared u. So you can take it, bring it back, and then say, therefore, du dx is equal to 1 over 1 plus tan squared u. And then you remember tan u is x, right? So you have du dx is equal to 1 over 1 plus tan u all squared. And since tan u is x, so it means that du dx is equal to 1 over 1 plus x squared. So that's your du dx. So, but later you need du. So du is actually 1 over 1 plus x squared dx, like that. And then you keep that and come back to it later. Now, so for the other part, right, you just need to integrate. So integral of dv equals integral of dx. When you integrate dv, you get v. Integrate dx, you get x plus a constant c. That's how you're going to get there. So from that, now we can proceed to the next thing. You can now say, therefore, I now, which is uv minus integral of v du, is the same thing as uv. U that we took is arctan x. So u is arctan x times v. V now, as we have here, is x. You can leave the c out for now until you get to the end. So that is x, that's times x, minus integral of v. V again is x, and du is what we have here now. Du is 1 over 1 plus x squared dx. So we can tidy this up. So we have I equals x arctan x minus integral of x over 1 plus x squared dx. Okay. So that what can we do here? Well, we can say this is I equals x arctan of x minus I1, because this one requires a bit more work to accomplish. So we can then come back and say I1. We can come back and say that I1 is equal to integral of x over 1 plus x squared dx. So that if you now say let q be equal to 1 plus x squared, that's what is down there. So dq dx is equal to 2x. If you differentiate 1, that's gone to 0. Differentiate x squared, you get 2x. So dq, so you can say that if you cross multiply, right, 2x dx 2x dx is equal to dq. So that means that dx alone is dq over 2x. So you have this, right? So you can take it back up there. So you can take it back, and then you have I1 to be integral of x over 1 plus x squared now is q. So you have q, the x is the q all over 2x. Thankfully, x cancels out. So you can have I1 to be, these two can come out as half integral of 1 over q dq. So, I mean, integral of 1 over q is simply ln q. So you have I1 equals half ln q plus c. And then since you did not start with q, remember that q is 1 plus x squared. So you have half ln 1 plus x squared, half ln 1 plus x squared plus c, right? So something like that. And you can now finalize the whole story. Okay, maybe I should change to something different. Let me change to this. Okay, so now you remember where you stopped before, that I equals x tan x arctan x minus I1. So you now say therefore I, which is x arctan x minus I1 now, is the same thing as I equals x arctan x minus I1. So that's minus 1 over 2 ln 1 plus x squared plus c. So that is the integral of arctan of x. So we have come to the end of that. So if you have not subscribed to this channel, be sure to do that. And of course, hit the notification bell, so whenever a new video is released, you can get notified accordingly. Then like, share, comment. Comment if you want us to solve a problem together, or you want me to explain a concept. I can take a topic and break it down from the scratch to the very end. And keep coming back. I appreciate your coming back all the time. So let's keep having a nice time doing maths together. See you in the next video.